We're really excited to have our speaker. Can you hear me?
Yes.
Okay, good. Lee, I was going to read his biography, but it was in the announcement twice. But he is an amateur. He has been an amateur since he was 15. He's spoken before on this topic at I think the North Fulton Amateur Radio Club, where I heard about him. And it's really exciting. I've talked to him several times on the phone and email, and he's talked me into buying one of these neat little devices, and I've played with it. We're also excited that next month we'll have John Clute, who's going to talk about the 4-year amateur radio upgrade on the ISS, International Space Station. We're excited about that. But right now, we're going to listen to Lee. Take it away.
First of all, thanks for the invitation, and I'm looking forward to doing it. It's always nice to do a presentation for the second or third time. My objective tonight is to share what I've learned over the past 18 months using the Nano VNA on a new crop of Infed antennas and the journey that I've gone through with building the homebrew antennas, thanks to Steve Ellington, a fellow you folks had, I think, a couple of months ago. This all started with Jim Stafford, W4QO, in his welcoming way at my second North Fulton club meeting about 18 months ago. And he had an article on the Nano VNA and said, "You're not going to believe this." And, well, you know how Jim is. And so he convinced me that it was something to look into. And I'm an engineer by training. And so I took to it pretty quickly. And what I'd like to do tonight is to get most of you familiar enough to see what your own specific use cases might be for such a device. And also show you the most popular measurements and how they're done. Some of you have probably heard how complex this thing is. You'd be surprised how simple it is once you set it up. It's not nearly as daunting as you might expect. I'd also like to convince you that it'll be the best $50 you ever spent. You'll be surprised. Get my slide to go here. I'll be all set. There we go. Again, thanks for the invitation. A little introduction. If there's a good time for a ham to get his license, it's during Sunspot 19 and 1957 timeframe. If you folks have looked at the sunspot cycle patterns, you'll find that was probably one of the best ones that's been around. And especially with a Hawaiian call, and you're a teenager in high school, it couldn't have been a better time to be on first AM and then finally on single sideband in the late 50s. Now I'm retired, once again back into the hobby with a 7300 and a stable of Infed antennas that I've learned a fair amount about, thanks to Steve and a few other guys that are forging a way into bringing those antennas into popularity, I think. I was a founding member of the Raleigh Amateur Radio Society in 1969. I built the W4 DW0464 machine in Raleigh and put the antennas up on the about 275 feet. For once in my life, and I'm an ex-paratrooper, so heights don't bother me too much, but I found myself on the outside of that tower with both hands off the tower and no belt on the tower. It was a split second of realization that, this is not a good place to be, but we got through it. I'm retired after about 40 years in the high-tech industry, and currently live in Marietta with my wife, the love of my life, and getting back into ham radio with HF, VHF, homebrew, and antennas. So that's where I'm headed with it. If you look at the agenda, it's pretty straightforward. go into the, what's a network, vector network analyzer? Why do you care, and what difference does it make to me? The next one is the entry of the Nano VNA on the scene, a little bit more detail about it, some specifics, some operational demos, some application examples that are outside the demos, but will give you a much better perspective of the breadth and depth of what you can do with a new device. Some references that might be helpful later on once you start getting into it. And then we can have a Q&A, and I've got the chat board up here so I can see that okay. I'll try to bring you some history on where the Nano VNA came from and try to bring you current as of about 3 days ago with regard to where it stands or where they stand. We'll focus primarily on the standalone use for the device. There's a lot of software you can add to it. You can put an Android phone on there. And so it's something you can really get into and do a fairly in-depth analysis and great graphics on it if you want to. But the standalone case, I think, is probably the dominant case for most of us. And I think you'll be surprised with some of the new developments coming along that'll make the standalone case even more obvious. Okay, here. This slide is an aerial slide off Google of my lot with the antennas plotted, north being straight up as you might expect. And this gives you a perspective of the red antennas is a off-center fed 80 meter multi-band dipole. You'll see the yellow chart, the yellow plot. That's the Infed, the 40-10 meter Infed with a bearing of about 330 degrees. And there's the pattern for it. And then also you saw an Infed up there in green. That's 90 foot vertical. It's an inverted L. And I found it wasn't the best in the world. I was surprised. The yellow antenna, which is a 40 meter antenna, gives me the patterns I'm looking for. You see the dotted blue line in my roof line. That's a 40 meter dipole inside the attic. I live in an HOA, but I've found a way to hide my antennas, and the red one and yellow one and green one are at the 70 foot level pretty much. I've been blessed with some good oak trees to work with. I've tried to plot the patterns of the yellow antenna facing or bearing 330, and the chart there shows you in blue what the 40 meter pattern looks like. Then the 20 meter patterns in green gives you a good perspective that I can get into Europe and also Asia, not Asia, Europe and Australia, New Zealand pretty well. The red pattern is 10 meters. And as you might expect, you get multi-lobing because of the multiple 10 meter half wavelengths. But this has worked out pretty well for me. And I've got on the right-hand side the nulls on azimuth and also the broad peaks. But the antenna works great with 100 watts. I can get into most of Europe without too much trouble. And I can do an S9 signal on 100 watts most of the time. So I'm pleasantly surprised with it and pleased with it. And Australia and New Zealand is not much of a problem, and South Africa works pretty well. So for 100 watts, it's my favorite antenna so far. The next chart shows you my beginning of, okay, I'm getting a 7300. I got to put up some antennas. I'm going to need some kind of device to help me out. And I was at the Ham Club or the Ham Fest a couple of years ago, and I saw this advertiser trying to sell boxes in the $200 and $300 range. And I borrowed the club's MFJ 200. I'm not sure which one it was. Antenna analyzer, and use that to get started with the Infeds and the off-center fed. And then all of a sudden, here comes the Nano VNA and Jim Stafford. So I start looking at what I might want to do with that, because I wasn't satisfied with the the non-resonant Infed antenna, and I was looking for something different. And so I went back to a little bit of my engineering background with vector network analyzers. And like some of you, I'm used to using, shall we say, analyzers that are probably 20 inches wide and 10 inches high, and sell for 50K in the business world. And most of us were using SWR meters or the MFJ type analyzers, and just didn't have the funds to really take a deep dive into what the antennas look like. And so I thought I'd back up here and start with what's a vector network analyzer, and then drop down into the Nano VNA version of it. But basically, what it does, it measures both the amplitude and phase of the reflections and the transmission paths. If you look at most analyzers, they have just one connector and you can hook it up to your antenna and take a look at it. This one has 2 ports. So it allows you to do not just the antenna analyzing, but also you can take a look at a filter. So you can put a signal into it and go through the filter and tune it, and you can look at the output. So that's the transmission property that I'm talking about. The reflection property is, SWR, reflection coefficient, return loss, and things like that. But basically, it's an instrument used to characterize RF devices, be they amplifiers, be they antennas, be they passive devices. And if you look at, let's see what network analyzers look like. The one on the left is a Roden Schwartz. That's probably a 10-year-old device. And they're in the 50K range on the used market, by the way, just to give you an idea what they're going for. The middle device, by the way, these are scaled, first order approximation scaled. The next device is a 5K unit that doesn't have the dynamic range of the larger unit and doesn't have all the properties you might like. And the one on the right is the Nano VNA for $50. And basically, the critique against the Nano VNA against the 50K version is that you don't have the dynamic range to work with. The device on the left's got 100 dB dynamic range. Dynamic range on the Nano VNA is in the 60 dB range on the lower frequency side, and goes down to 40 dB when you get up to a gigahertz or 2. But they're getting better. The improvements are coming along, and you'll be surprised at what they can do. The other thing is the Nano VNA only does 100 points on the screen. So if you're looking at, let's say, 0 to 30 megahertz, you don't get a good look inside the 40 meter band, because the 100 points at 40 meters on a 30 megahertz scale is 350 kilohertz. So it can be outside the band of 40 meters on both sides. So you need to narrow it down and go to look at 40 instead of a broader range, but the device has that capability. So you don't give up anything except the money you pay for it. So you'll be surprised, and I think you'll be pleasantly surprised at what you see the unit does. Here's a block diagram of all 3 devices I just showed you. Basically, you've got a source, synthesizer, whatever it is. You've got splitters. Some of those can be directional couplers. Some can be bridges on the front end of the source coming in. So you've got the wave, the signal going in, the reflection off the unit under test, the DUT. And so that gives you the both forward-looking signal and the reverse signal on the input. And then, since it has a second connector and is built to do it, you've got the output path that you can take a look and look for gain or impedance on the output side. You can look at frequency response. phasing, and it gives you a fair amount. What you've really got, if you take a look at the synthesized software-defined radios, little dongles, imagine the step from a vacuum tube R390 to that small $29 device plus a computer. What you see here with the Nano VNA is a similar step for vector network analyzers. Okay, and let me show you what you can do with it basically. Again, it's a handheld, low-cost vector network analyzer. Think about it this way. It's an RF multimeter capable of measuring electrical parameters of antennas, filters, components to 3 gigahertz. Okay, so on just the reflection side, like a normal analyzer, it's by the way, in the scattering parameters, it's called an S11 port. It's going from port 1 to port 1. So it's the incident wave going in and the reflection at the same time. So there's where the SWR measurement comes from. You can look at the complex impedance of what the real or resistive impedance or resistive impedance is, as well as the imaginary or reactive impedance. So that gives you the complex load impedance. And you can look at it right down in the band and see how close you're getting to 50 ohms and what the reactive impedance is and give you an idea of how you might want to match it. You can look at splitters and diplexers. This unit's got a little bit of trouble with the dynamic range on, a real good diplexer. So that's one of the shortfalls here. You can look at a filter on a return loss on the input side. You can look at the amplifier return losses, cable impedances, the feed line length for, a TDR kind of measurement, time domain reflectometer kind of notion, and then look at the distance to a fault. You can find out if your balance bad or you've got a connector problem, something like that. You can look at the transform methodology here and actually look at, let's say a 75 ohm piece of cable tied to a 50 ohm piece of cable. You can see that junction and the difference in how far out it is. Excuse me. If you take a look on the transmission side, in other words, going from port 1 of this device to port 2 of the device, you can look at a filter, tune a filter, look at attenuators, flatness, delay, that sort of thing, power splitters, balance. You can tune your phasing networks with it. You can look at devices, unique devices like crystals, resonators, amplifier gains and delay, and you can look again at cable loss, length, and even velocity factors. So there's a set of measurements that for 50 bucks, they all come, and all you have to do is spend a little time and a small learning curve to get up the curve here. And so it turns out that this is kind of the geek toy of the year last year. Okay, a lot of you probably got them for Christmas this year, but some of us who had an inkling of what they could do a bit early, and if you got the right device, you were okay. If you got the wrong device, it failed or didn't do what you were looking for, because most of them were Chinese copies, and you couldn't tell from the Amazon ads which one was real and which one wasn't. The picture on the left is my device with a case on it, and that's a measurement of the frequency response and return loss or matching on the input side of an 88 to 108 filter for getting rid of the FM band, FM broadcast band. The picture on the right is one of the newer devices. That's the Nano VNA Fusion H4. It's a 4-inch screen, and you see in the picture what it comes with. You get cables, small, short interconnecting cables. You also get a power cable, and the small pieces on the left are the open, short, and 50 ohm load points that you use for calibration. So that's what you get in the box for about 50 or 60 bucks. That's the price range the going price range now. If you look in a little bit more detail of what I bought mine in September of last year, and I bought it off Amazon. I know the name here from past experience. So I paid a little bit more than the $50 to make sure I got a working device. And sure enough, this is the current platform that probably is the most popular one. It comes without a case. You got 3 printed circuit boards stacked up together. And I took the cover off mine. The top picture on the right-hand side is the back cover with the unit showing you the screen. And the bottom picture is the cover, same cover basically, showing you what the unit looks like on the other side, which is the battery in the bottom, the shielded mixers on the right, and the rest of the DC lower frequency components on there. So you can see there's not very much to it. Most of the parts are integrated, have been in volume for years. And so from a parts list, it's a pretty economical device to take a look at. And most of the work is done in firmware. If you look at the background of where the Nano VNA came from, the original design was done in Germany and was published in QEX in, let's say, I think, March, April timeframe of 2007. People started to see that, and a Japanese ham called Eddy 555 actually built the original Nano VNA that you see in the Amazon ads with no cover on it. That's pretty much the successor of what Eddy did, and that was in 2016. Well, Hugen 79 and a lot of clone manufacturers spun up rather quickly in 2018 and 19. And so you've got a lot of devices that are really not all that useful and not all that capable. But the Hugen 79 basically took it on and productized it and marketed it. He's a Chinese ham. And the original version that a lot of you might see on the screens you've seen so far is the Gen 111 taboo.com firmware listing. Okay, it's been extended to 1.5, and that's the foundation for the device you see on the right, which is a Hugen H4. What's happened since then is that the evolution is continuing. The evolution's continuing, and they've gone to 4-inch screens. They've gone to 3 gigahertz now. There's a second variant that is a different hardware design, different firmware design coming out to compete with this original version. And there's also on the original version an extension with an SD card slot coming. Some of you may have seen it in the hardware already. It's not in the firmware yet, from what I can tell. But basically, the disadvantages of the standalone unit heretofore have been, once you turn the unit off, what's on the screen goes away. And there's no way to store what's on the screen except using your iPhone or your Android to take a picture of it. So the trick now is if you add the SD card, the hope is that you'll be able to save those screens. And so you won't need to go to using the computer adjunct to do the plotting. We'll see how that turns out. They've also looked at adding on the firmware side the time domain reflectometer functionality, and also some more changes on the hardware side to do the tiny spectrum analyzers. You'll see those starting to come to market now. The good news of these devices is they're all public domain, or for the most part, they're public domain devices, meaning that the firmware and the hardware designs are not copyrighted, and so they're usable. You can buy them. There's no real license fees on them, and there's a lot of people supporting the software designs with features and functionality. So that's the richness of an open architecture, and both on the hardware and software side. Now, as of today, the best option if you're going to buy one is the H4 model, the Nano VNA H4 model by Huge 79. And there's a second version coming that's probably going to take the dynamic range by 10 or 15, maybe 20 dB, and also take it up to 3 gigahertz in case you want to work higher than 1.5. So that's an option for you. So that's coming along. So those are the two, if you will, forks of the hardware, and the software is continuing along, again, forks to match the hardware, but features and functionality are coming along pretty quickly. Now here's the block diagram. It's a rather straightforward one. I won't spend a lot of time on it. What you'll see in the lower left-hand corner, and I think I can probably put my pointer up on the screen. Can you see the pointer okay?
Yes.
Okay. I won't use it much, but that's the synthesizer and the clock generator, basically. This thing puts out a square wave, and they use the harmonics to be able to go into the mixers up here and give you the demodulated signals at audio baseband kind of frequencies. And this codec right here is basically the conversion from the analog domain to a digital domain. And then you hit the microprocessor and away you go. So that's the device. It's fairly straightforward. All of those devices are in very high volume, so they're very inexpensive. This codec is the fundamental codec that they use in things like cell phones. So you can imagine what the volume is. Here's the schematic. It's probably pretty small. I chose just to put it on one page and not blow it up, but you can see a little bit of the, here are the mixers right here. Okay, and then you see the larger blocks. I think that's the signal generator, and then the microprocessor and some of the other parts. And if you look at the specs, the new ones, the H4 model go from 10 kilohertz to 1.5 gigahertz. And it does a pretty good job across that span of frequencies. It's got a 0 dBm output or a 1 milliwatt output. It'll peg an S meter for you. You stick it into your receiver, just to give you an idea. The dynamic range on the low end up to 300 megahertz is about 70 dB. So it's not the 100 dB that you can get from a $50,000 device, but it's plenty. Even up in the 900 megahertz to 1.5 gig, 40 dB is plenty to do the kind of work we're doing them on. I mean, you couldn't, you probably couldn't tune a diplexer for a cell tower with it, but I'll pass on that for $50 anyway. The display is a 4-inch display if you really want to see it, especially those of us that are over 70 these days. USB-C type interface for both data and power. Battery on this one is 1900 milliamp hours as opposed to the 450 that's on the original device. You get 100 scanning points, and that's okay. If you think about it, if you're taking a look at the range of a 80 meter to 10 meter off-center fed dipole, you've only got about 300 kilohertz worth of distance between the points, but that can miss a whole lot of the 40 meter band. So if you want to look at 40, you need to truncate the bandwidth that you're looking at to say 6 to 8, and you get 100 points across that. Or if you want to go from 7 to 7.3, you get 100 points across that. So it gives you plenty of fidelity if you want to take a look at a small part of the band. You got 4 traces to work with and markers, memories for calibration. So the device as is, without an external computer, has a fair amount of functionality. The synthesizer is rock solid. You won't see it moving around at all. And
question.
yeah,
It's confusing. The frequency range says 10 kilohertz to 1.5 gigahertz. How can you use that on 7 megahertz?
how can you use it on 7 megahertz? Well, 7 megahertz is between those two numbers, right? What you do is you set the, I'll show you later in the detail, but basically what you do is you go in and set the start and stop of the frequency spectrum you want to look at. So you can look at any individual band, and you can look at, let's take 40 meters as an example. If you want to look at 7.0 to 7.3 and see where the SWR nulls are, you can look at that. You've got 100 points of accuracy to look at it with. If you miss the 40 meter band and you're trying to tune your antenna, you might like to look from 6 to 8 megahertz and find out where it's resonant. And so the idea is that you can set it for whatever frequency band you want to look for. And if, let's say you want to look for a VHF whip antenna on your 2 meter, 440 meter walkie-talkie. You can set it for, let's say, 120 to 500 and look at both antennas at the same time. The real question is, at what detail do you want to look and how narrow do you have to make it to find that detail? Does that answer your question?
Probably not, but it's just my own lack of understanding of all of this.
No, not to worry. We'll get into it a little bit later, and I'll show you the graphical perspective of what I just said in a lot more detail. And by the way, all of us had to come up the learning curve with this stuff, and it's like a fire hose. But hopefully, as a result of this presentation and some time with the device, you can throttle the fire hose back and aim it the way you want to go with it. I think you'll be pleasantly surprised. The nice thing about it is you can go, it does 2-port measurements called S parameters, and we'll show some of that, but that's not an S parameter detail in the Smith chart is not something you need to get into with this device, but it's capable of doing it. So if you look at the device itself, I tried to give you 2 views of the device here. One is the physical view, and one is the menu screen view. If you look at the device on edge, on the top, you see the USB port, the battery LED, the power switch, the system LED, and the rocker switch. It's a multifunction switch. You can go left, you can rock it left or right, or you can push it down. A lot of people don't like that switch. A lot of them have been broken, but they work fine once you get used to it. If you'd prefer not to do it, you can use a pointer on the screen and use the screens that you see on the right to do the same thing. So you don't need to use that device, but you can go either way. If you look at the screen of the device on the left, don't let that scare you. The one thing about the Nano VNA, when I first turned it on and got it home, it looked a lot like that. And I thought, I'll never understand this thing. That's 4 traces on top of each other for all different functions. So with a computer, you can separate them and look at them separately. With a Nano VNA, you can overlay them, or you can turn 1 on, 2 on, or 3 on, and I'll show you that detail later. You don't have to try to decipher that screen like that. And I'll go into, if you look at the bottom there, it shows you channel, format, scale, marker value, marker, the activated markers, the frequency, and the calibration status. Okay, we'll go into those details in a fair amount, but you'll see them across the top of the screen of the device and the bottom of the screen of the device. If you look at the right-hand side, this screen is the first one that pops up. This is the default screen right here. So that says display, Let's see if I remember what that says. I forgot what that says. And I can't read it very well. Sorry about that. But basically, that's the default and it's a starting point. It gives you the displays, the markers, the stimulus, the calibration, and then the close on that. And if you look at the display, the top line across the right shows you traces, formats, scale, and channels. Channels meaning the channel 0 and channel 1. It's really just port 1 and port 2. Second one here gives you a sense of whether you want to add something, select a function, or you want to search for something like a minimum of SWR. It'll actually go out and show you the minimum with the marker with the firmware. If you look at a stimulus, let's say you're looking at 40 meters, you can set the start, you can set the stop frequency, or, excuse me, folks, you can set the center frequency and what the span's going to be. So you got two different ways of setting the sweep frequency of the device. And then the bottom one here is calibration. Some of you may have heard a lot about calibration, but it's basically making up for the shortcomings the device has. So if you want to look at 40 meters with a lot of data points, you have to calibrate for that frequency range. If you want to look at a broad antenna to see what the multiple resonant points are, just as a first order approximation, then you need to calibrate it for that frequency range. It's not that difficult. It's fairly straightforward. The screen on the bottom is another screen which shows you the one level down, what the next level down gives you in terms of the menu. The next screen over will show you more detail, but I thought these were the top two screens that would be useful for you. This is the data entry screen. So if you, let's say you took 7 megahertz, you would just hit 7M, and that would be the start frequency. You go to stop and hit, let's say, 7.3 and hit M, and that would be your stop frequency. Okay, and then it would plot from there. That's all there is to it. Okay, here's a software designer's version of the menu structure map. This is the only manual you get in the box with the unit. You don't get any of the rest of this stuff. So what you get is a software guy trying to tell you from a backwards looking view how the unit functions. Because you're starting over here on the left-hand side and you have to decide what kind of display you want, what trace you want, what traces you want, what color you want to run in. And you end up with like I said, a software developer's point of view of what this unit is designed to do. It's hard to take this chart and say, okay, I want to measure SWR. Where do I start? So the functional view of how to go through the menu isn't on this page, but you learn it pretty quickly. As an example, if you take a look at, if you want to take a measurement with a device, before each measurement, that's not true. Before each type of measurement, you need to decide how many traces you want. Like if you want to do SWR, you can pick one trace. Format, that's SWR. Channel 0, because you're looking in the one port and the reflections off that one port for your antenna. Scale, do you want the first line up to be a 2 to 1, 3 to 1, 4 to 1, or you want it to be a quarter, half, 3/4, and 1 to 1. So you can set the scale going this way as well. The reference position, for SWR is 1 to 1 is the bottom line of the display. Okay, but you can set that reference position at different places if you choose to. And then the calibrate, that's just a calibration procedure that we'll go through on the next slide. And basically, you can even set, what I've done is I've taken let's say 10 kilohertz to 30 megahertz as one calibration. And the next one I've taken is 80 meter calibration, 40 meter calibration, 20 meters, 15 and 10, and stored them. Well, I don't have to calibrate it again. I can just use it like it is. So there's an example of simplifying the calibration process by using what storage they've got on the device. The Absolute Beginner's Guide to Nano VNA by Martin here is one of the better works I've seen from a contributing engineer type guy that's a ham that wants to help out. So that's a nice reference source, and that's listed on the back page of this presentation. Okay. Here's the calibration I was telling you about. And basically, if you look at this portion of the screen right here, where the arrow is pointing, okay, it's the same as it's CDRSTX is what the letters are. The top letter is calibration, and beside that C is which calibration location you've got stored and recalled. If you have a capital C, the device is telling you it's calibrated for the scale you're trying to measure on. If you have a lowercase c, it's telling you you need to calibrate. Following that C is where the calibration scale is stored. And down here is the open, which is a hollow SMA connector, a short, and then a 50 ohm load. And those are the loads that you put on this port as you go through the calibration procedure. I'm not going to go through that detail here in this presentation. There's just not enough time, but it's a fairly straightforward thing. Basically, you set it up for calibration. You put the open on there. You hit the open on the menu. It goes to short. You put the short on there. You hit the load on the menu, and it just goes down and ripples through, and you're done. There's no adjustments that you have to make. The units is self-calibrating as it goes through. Okay. All right, now let's take a look at, let's say you want to measure SWR. Okay, it's probably the most common measurement that most of us take. I'll show you two videos. This is the first one. This is, excuse me, my Infed antenna going from a 50 kilohertz starting point to a 30 megahertz point. If you look at, let me calibrate your perspective here a bit. This is SWR plot, as you can see up here. Are we still on the same scale? I saw something jump and I wasn't sure what it was. Okay, here's the SWR scale. Channel 0, SWR, and it's a scale of 1. So this is 1 to 1, this is 2 to 1, and this is 3 to 1. So you can see this antenna starting at 6.9 megahertz is staying pretty close in the bands you want to work, below 2 to 1 with no tuner. So this is encouraging when I started working with this compared to using the non-resonant infeds. This is a resonant infed. This is a 65-foot wire with a 49 to 1 transformer from Steve Ellington's stuff that you all looked at a couple of months ago. So, and here's the SWR at 6.938. And that's a little outside the band, but it's up 70 feet and I'm not taking it down. And if you look at what it looks like over the 40 meter band, it's still less than 2 to 1 across the whole 40 meter band. But you can't really see that here. All right, but that's a marker that you can move and it gives you where that marker is. And this goes up to 30 megahertz. So that's a first cut look. I'll start the the video here. And this will give you a better perspective of what the bands look like. There I'm picking up the menu, stimulus. I'm picking a stimulus And now I'm going for 40 meters with a broader view, going from 6 megahertz to 8 megahertz. There's a stop frequency. And there you are with the SWR curve going from 6, there's 7 megahertz. You can see the number in the upper right hand side going. I'll stop at 7.3. So the center line is 7, and that's 7.3 megahertz. Okay, so that gives you a way to look at what the frequency is and what the SWR is, and it's 1.65 at 7.3. So that's good enough for me. The next one, we'll take a look at adding on top of that trace a return loss trace, okay, which is, if some of you are familiar with return loss, you'll understand. It gives you a sharper view of the resonant point. I had to go through a couple of brain freezes trying to set this up. Okay, here's a look at the resonant point in more detail. This is 0 return loss. This is 10 dB return loss. This is 20 dB, so it's got a knot. That's 40 dB. That's really a nice resonant point, but it's a lot sharper than the SWR resonant point, and it's at 6.98. Okay. Now, there's a Smith chart laid on top of it. For those of you who are familiar with Smith charts, you see the 1 marker, the green 1 marker. Notice in the upper right-hand corner, it says 50.2 ohms and 17 nanohenries. And as you move the cursor, all of them move together. And so you can get a sense of, okay, at 7.3, that antenna is down to 46 ohms and 524 nanohenries reactive impedance. Okay, so there's the 3 charts laid together, and you can drag them across the band like that and get a really good view of what the bands look like. Okay, and I want to go back and show you this chart. This is the first chart, but I got into this chart and I realized that I could tell the temperature by where the resonant point was on the antenna. I'll show you what I mean. I didn't understand it at first. This is a plot on a broader perspective. There's 40 meters, and we'll go through that. Let me speed it up a little bit here. Okay. That wasn't the one I was looking for. This is the one I was looking for. Sorry about that, folks. Well, I can't get back to that slide. Why can't I get back to it? All right. Let me start it up again. Okay. This is what I wanted to show you. This takes a look at 40 meters and gives you a bit more detail. What I tried to do here was to show the resonant point, which is outside the 40 meter band, which is right there. Shows you a real sharp null here. And here's the SWR. Okay, and the SWR is 1.03 at that point right there, which is a null. Okay, so it goes up from 1.03 to 1.65 there. Okay, and what I found out in making this presentation was that this point moved around on me with temperature. So I did the presentation and I was finishing it up at 1 o'clock in the morning, and it was cool. And the chart looked different than when I was working on it in the afternoon. And what I realized was that 20 degrees was about a ½ an inch or 3/4 of an inch on the length of the antenna. And so it was moving that null point on, actually when I was measuring it, I was measuring it on 10 meters. Okay. And so the null point, well, let's don't worry about that. Okay, let me bring this next chart up and we'll move on. Here's a look at my off-center fed dipole. And there's a top chart there is 50 to 30 megahertz. The bottom three charts are what the bands look like on that antenna. So that gives you a perspective. And you can set the edges of the band here if you want to the actual band edges, or you can set them to where you want to based on if you're not inside the band with your resonant points, you can go outside the band and take a look at it. So that's one antenna. The other antenna here is a 40-meter dipole I had in the attic, and you see the resonant point at 7 megahertz, and then the harmonic 15 meter band, 21 megahertz. And here's the resonant 2-to-1 points at the band edges, basically. Okay, that's 7.0. Actually, this is 7.4. And there's the null point for the SWR. There's a Smith chart plot just to give you an idea of what it looks like. So there's 3 different antennas plotted. And now you say, well, how do I know that SWR is right? So if you take a look at this, here's a comparison between the Nano VNA and the Icom 7300 SWR plots for the graphs. So if you look at the top chart, that's 75, 80 meters. And if you look over at the left-hand side, you'll see that the 80-meter marker over here, number 1, is at 6.9. Well, if you look at the SWR graph on the 7300, there's the bottom end right there at 6 point something or other, and it's basically 1-to-1, and it says 1.09 on the other side, and it goes on up a little bit. But even when it gets to 7.3, it's still below 2-to-1, which is the below 1.5-to-1, which is the red line, and that's without the tuner running in the 7300. So the nice thing I like about this is you can actually run less than 2-to-1 for the bands of interest with no tuner. And that's why I've really kind of gotten into the Infeds. You can look at the 10-meter chart, and there it is across the whole 10-meter band, and it never gets to 1.5-to-1. So there's a quick comparison between the Nano VNA for 30 megahertz window, which is pretty wide. You can get the same charts, and here's a 7 megahertz window of that antenna, and you can see that from 6.5 megahertz over here to 7.5 megahertz over here, it never goes above 2-to-1. Okay, and there's the null, and there's the 50 ohm point on the actually 48.5 ohms on the Smith chart. So that's SWR. It's a pretty capable device, as you can tell. And then you can take a look at measuring filters. Here's a 80 to 108 band stop filter with number of plots you can look at. This is my device. This is my device with a stand on the iPhone taking pictures of it. So there's you can use it for that type of measurement. You can also take it and look at the radiation pattern of a Yagi if you want to make your own range with a UHF or a VHF antenna. Get a little bit outside the near field, set the device up, run a piece of coax back to the antenna, use both the channel 0 and channel 1 ports, and you can actually measure what the propagation pattern looks like as you rotate the antenna, and you can plot it, and then you know what your antenna is doing. So there's a radiation pattern. A little tough to do on 40 meters on the ground like that, but for a VHF and UHF antenna, you can certainly do it. So there's another use for the device. Here's a time domain reflectometer perspective. If you can look here at piece of coax, here's where it changes from 50 ohms to 75 ohms. And here's Actually, this is where it's open on the end. And so you can get an idea that you can actually see where the instances of impedance change are along, say, a bad connector, a connector with water in it, things like that. So you can actually get the distance in feet or meters. Okay. You need later software than I've got on my antenna, but you can get that software off the open source at GitHub and download it and flash your VNA device. And
You have to put in the velocity factor of the cable.
The answer is, since I've not made this measurement, probably so. You can measure the velocity factor of the cable with the device if you want to. If you just,
Okay, so if you have a couple feet of it, you tell it how many feet you measure,
right.
and it measures the time from what does it do? Put a pulse in and
Yes,
wait till so it is a true TDMA.
that's correct. That's correct.
TDM.
TDR,
okay,
right.
TDR. So it sends a pulse and times the pulse.
It sends a pulse, and if the cable's open or short on the other end, it'll reflect the whole thing back, and you can measure the time, and then you know where you are, how far
Okay.
out that pulse is.
I understand that one.
Yeah.
Okay, thank you.
Okay. My pleasure. And then here's the external software you can use. You see these plots, a lot cleaner, single plots. There's a lot of written on this slide, but I won't read it all. But basically, with PC or software you can load on a Mac or something else, you can actually hook it up to the USB port and drive the device from a smarter interface. And there's software packages that are available for that. The most popular one I've seen so far is the Nano VNA Saver. And you can set up the device just like the menu we're looking at on the Nano VNA, or you can do more complex measurements as well. And you can certainly get a lot more points. I think some of these things have gone up to 10,000 points. So you can get a lot more finesse on the graphical side. But, you know, if you're measuring a resonant point and the endpoints on a 40-meter antenna, 100 points is, you know, plenty good. And you don't need a computer to drag, you don't need to drag a computer out to your antenna. So that's why I'm a big believer in the standalone device. But a lot of people like these, and there's a lot of guys out there doing. I think the name of the files are called touchstone files, and it's a pretty common used format out there. Okay, here's the sources and links that I've listed for references. The first one is just a pretty good introductory video. The next one is some of the groups, IO forums that you have. Then you got a user guide there, the absolute beginner's guide we saw earlier, and the smaller print is the links to those. W2AEW has a YouTube channel that has a tremendous number of Nano VNA slides and videos up that are quite helpful. The Nano VNA Saver I just told you about, Rune Broberg did that work. And then there's a Smith chart video if any of you want to dive into Smith charts. The next one is the two groups. The first group on IO is the original architecture. The second group, it's called a VNA2, is a new hardware architecture capable of broader dynamic range and higher frequencies. So you got two groups up there to take a look at. They're really active and they're quite helpful. You'll be pleasantly surprised. In summary, basically, the Nano VNA is, I think, a software-defined RF tool extraordinaire. You can do a lot with it. And the good thing about it is they're adding functions and features, and the architecture is open. So a lot of people are contributing to it, and there's a lot of force behind this thing. You got the user groups and the YouTube videos. There's thousands of YouTube videos out there on this thing. And probably the best US source that I found so far at the price is R&L Electronics for 59 bucks. You can get the H4 version. Now he's probably only got 25 in stock at any one time, but if I was buying another one today, that's the one I'd buy, because the version 2 hasn't been out long enough, and the H4 version is pretty mature in the firmware, and they're adding functionality to it all the time. So that's a good place to start. I paid 75 bucks for my first one. I can't do TDR on mine, but I just haven't uploaded the firmware yet. And my original one's good enough, so I'm going to wait a little while longer and see what the version 2 spur does, or version 2 fork does. Okay, I got a test question. Can anybody tell me what kind of an antenna that is? That's a Smith chart. The green part is a Smith chart plot, and the plot on the bottom is SWR from 50 to 900 megahertz, and it doesn't hardly go much over 2 to 1 for that whole frequency band.
Long periodic?
Nope.
I would say it's a disc.
Discone?
Yeah, a
You
discone.
got it. It's a discone. You got it. I was going to be disappointed because the guys over at North Fulton got that one. Actually, only one guy got it after about a minute and a half. So,
Or you
I
could
know-
say
I
an
know it's-
MFJ dummy load.
Probably not quite. Not quite. Okay. We can go through some questions if you like. I'll be happy to do what I can to help out. Any
I
questions?
got a quick.
Thanks-
I have
thanks
a
for
quick
listening.
question.
Sure.
Excellent presentation.
you.
Really, really professional. I'm interested in using the Nano VNA as a field strength meter, in addition to all the other stuff.
Mhm.
Any recommendations?
You can do that. There's 2 receivers on this thing, and 1 on each port. And you can put an antenna on there, and you've got a graphical interface that you can set the frequency range on. You can set a CW carrier in there, and you can go towards your own receiver with that as a generator, or you can go the other way and use it as a field strength meter with some sort of an antenna you might want to put on there. So yeah, you could do that.
Thank you.
I assume it's also a signal generator for that, although I guess you'd have to add an external attenuator.
Well, yeah, if you think about it, it generates a square wave, and a square wave, unless it's has a frequency slope to each one of those harmonics.
It's an infinite frequency generator.
Yeah, like the old calibration markers we used to get on our old radios. But the good news is it's got a 0 dBm level signal in the first half of the frequency range, so it's strong enough to do something with. But yeah, you need an external attenuator, and the unit is probably not shielded well enough to help you out a whole lot. Because if you look at the original unit, there's a single shield, but the whole unit's not shielded. So you got fast edges moving around that circuit board, and it's not clear to me how much isolation you're going to be able to get with an attenuator.
Would you mind going into just a little more detail on how you would actually set up the Nano VNA for that field strength measurement?
Okay, well, let's see. If you look at, let me see if I can. Just thinking about, no, I probably can't do that. One of the choices I had when I made this presentation was, do I actually have a live device in my hand, or do I make videos of it? And I chose to make the videos of it. And so I thought to myself, okay, what if I get asked a question like the one you just asked? How do I show you that? But basically, let me back up and try to do a first cut at it. Okay, if you look at if you look at, for instance, the traces, um, you can you got 4 traces to work with. So you pick one trace, okay? And you can actually see the signal if you're looking at it on, let's say, any of the receive or reflected. Let me be more careful.
What kind of antenna would you put on that?
Well, you know, most field strength meters have just a piece of wire, you know, a small little whip on it. And I don't think there's no reason you couldn't do the same thing again,
Thank
because
you.
it's just going to be attenuated, and you could do that. But I don't see why you couldn't put an antenna on there and actually use the receive part of this device. And it's got a receiver on both ends. You have a calibration. Let's see here. Let me think about it just a minute. If you look at this device, if you look at signal strength, you know, you can actually, this has about a 40 dB dynamic range, 40 to 50 dB dynamic range. So the question is, you know, do you have enough range there from top to bottom to be within that with the signal strength meter? And so you might have to either put an attenuator in it or put an amplifier in front of it. But I would think that depending upon what kind of, you know, if you're looking for a field strength meter for an antenna that you got a transmitter behind, I don't think it's any problem doing that unless there's a shielding issue with the device and, you know, separating the printed circuit board from the antenna to be able to give you respectable, accurate readings. That's the only thing I'd worry about. If you're
Excellent.
picking
Thank
something
you.
up off of the air and you got an open device that's got you know, just a minimal amount of shielding on it. But let's put it this way, it's worth a try. I just built a field strength meter and a digital voltmeter and hooked it in there, and just took an old digital voltmeter and built a field strength meter in. It worked pretty well. I was surprised. So this unit's a lot more capable than a digital voltmeter is.
With the new unit, could you set it up and use it at 2.4 gigahertz as a field strength meter?
Sure. No reason not. Like I said, if you look at the block diagram of the unit, it's got basically in software, once you get through the mixers, it's got enough dynamic range to work with it. Because, you know, here's an example with a radiation pattern. I mean, that's really what that is. You've got a whip sitting there, right there. You got a piece of coax coming in, and you're feeding that antenna, and there's your field strength meter measurement right there, because you're using it as a signal generator. Well, if you got this antenna with a signal generator on it already, all you need is a whip and the measurement, and set it up and do a measurement on the vertical scale. And it's plotted, it's pretty accurate. I was pleasantly surprised at how accurate this device really is. And you get a digital readout as well as the graphical readout. So you can tell down to 2 digits past the decimal point what the actual level is.
If you just wanted one frequency to hold it on that frequency for a signal generator, what do you do?
Well, I guess the same thing you would on your receiver, right? You have to tune to that frequency. And the nice thing about this device is an easy way to tune for it is to start wide open, and you'll see the carrier in the middle, where it's hopefully someplace. Or you can, you know, let's say you're looking at it from a 2-meter repeater, just put the 2-meter band on there, and it's going to pop up somewhere in the middle. And you've got the vertical scales across the whole screen that you can set the levels with or read the levels with. So I think it's a pretty simple thing to do. I wouldn't see why you couldn't do that.
Yeah, well, I just remembered that I had the old Tentec VNA, and you could choose one sweep or repetitive sweep, and
Right.
it would stay at the frequency at the end of one sweep if you wanted to. And I just wondered if this had that capability.
Well, this has continuous sweep on it, so you can actually see what it looks like.
Yeah,
And
I understand what you're saying.
The one thing I've done with this is I've taken probably 1,000 pictures of the Nano VNA on the antenna outside with my iPhone, because I had no other way to capture what the plot looked like. And some of the plots you saw tonight came from those pictures. And the nice thing about what I see coming with the current VNA design is they're adding the SD card to it, and that'll allow you to make screenshots without having to use a camera or an external computer. So it'll
Did
store
you
the
did you
screenshot.
say there's either iPhone or Android software for this so that
Yes,
you can be outside and grab it on your phone with, as long as you have a cable.
right. That's correct. You can do that.
So so even if you get the one without the SD card, if you have a cable to your Android or iPhone, you've got it made.
Yeah, but you still got a small screen you're working with, right?
Well, you're always, either way, you've got a small screen until you put it on your 27-inch monitor.
Right, but you're not going to take your 27-inch monitor outside.
No, okay, but to save for now, if you buy the one you just said, I'm
Right.
assuming you don't get the SD card, or do you?
No, well, that was the point I was trying to make. I'm an old development type guy, and typically you bring the hardware out first, and the software's in development, and you bring the software load once you got the hardware population propagated. So I have seen pictures of the device that are being sold today that have the SD card slot on it. I have not seen the firmware yet, but I've heard discussions about the firmware on the IO groups. So the answer is you have to look inside. And the one thing what the standalone case to me has turned out to be the most useful, because if you're willing to take the pictures or with the SD card, if you're taking pictures, you don't need to have some other level of complexity and software interface to deal with it. You got the raw device in real time. And to me, that was worth a lot more if I'm out there tuning an antenna than bringing it back in and hooking it up to a big computer, or to futz with the software to try to get it into a Mac, because I've got an iPhone. And I think the dominant platform for using a cell phone is on the Android side. So I didn't venture in that direction. So that's why I'm being a little obscure with my answer, because I really don't have a lot of experience with it. But it's seriously, folks, it's the best $50 I ever spent, and I've learned a lot. And you can tune that 49-to-1 transformer with it down to the NAT, and you can tune the antennas. And I've been pleasantly surprised that how well there's an agreement between what's on the 7300 SWR stuff as well as this device. So I've not been disappointed yet in what I've found so far with it. It's been most capable. So I wish you well in playing with them. You'll have fun.
All right, we got a question on the chat from Dave Ritchie. He wants to know what the processor architecture is underneath this thing, and is it hackable?
It's the it's not an 8600. It's the newer. It's the same kind of processors you have in the iPhones and the Android phones.
The ARM processors?
Yeah, that's what it is. I couldn't think of the ARM term, but that's what it is. And in fact, let's see if I get back to it. We've got the device number here on the. Like we can find it, I think. Yeah, there it is.
So do you know if there are any third-party open source firmwares, or is it just one firmware that's
No, there is a gazillion firmwares, versions of it. There is a primary thread when you buy the platform. You know, when you buy the unit, it comes with the firmware of the supplier that you bought. So if you get the H4 version, you get their primary thread of firmware, and there are variants with that, and you can update it and add features and functionality to it. But there's an awful lot of extra firmware on the IO groups that is available directly off of GitHub, which is the repository for open source software and firmware.
And that schematic that's shown as an eye chart on this presentation is available on the internet.
Oh yeah,
Now you can zoom in on that and see how everything's wired together.
right, right. It's a pretty generic device if you think about it. It's just a a series of mixers. It uses hardware that was popularized during the cell phone era with regard to the digital signal processors and the cheap microprocessors. And so the bill of material price on this thing is probably less than $20.
Hey, Lee, I have a question.
Yes, sir.
So when you've read online various users of the Nano VNA flashing their devices, have you heard of many users that have bricked their devices?
A few. And I haven't tried to flash mine yet because I haven't seen enough value in taking the risk yet. There is talk of bricking them, but it's in the noise level. It's not a dominant thread of discussion.
That's very good to hear. Thank you.
By extension, is there any really common ways that you could fry this thing like you would an SDR by overloading it?
Oh yeah, you can certainly fry it because if it's hooked to your antenna, I mean, you can certainly fry it.
Sure. So do you know the max power it can take in dBm by chance?
No, I don't. But I wouldn't think it could take a lot.
I have a hack RF unit that can only take about 1/10 of a watt before it'll fry up. So yeah, I would assume that it would probably be similar with some hardware like this.
Yeah. The gutsiest I've been so far is I hooked my Nano VNA up to my 7300 just to see what I unhooked the microphone before I did that and made sure the Vox was off. But I wanted to see what it would look like on the S meter with the as a signal generator, and it was S9 over 60 over S9, and it was solid as a rock. And you could walk it through the 7300 and lock it up, and it was dead on frequency. So it's a pretty good standard from a frequency standpoint. I was surprised.
One trick a friend of mine taught me was that if you're out in the field and you've got a picture on your screen that you'd like to save, just hit the pause button, bring it back inside the house, take your iPhone and set the lighting the way you want it to snap a picture of it on the iPhone.
That's right. That'll do it.
That's more or less how Lee made the videos.
Oh, listen, you should have seen me. I spent a lot of time trying to make the exposure right. And I've learned how to freeze the stops on the iPhone camera to get the white part of the number pads from blossoming out to a point you can't read them. It took a while to get that done.
All right, sounds like our questions are winding down. Lee,
Okay.
Excellent presentation.
My pleasure. Thank you folks for listening.
I noticed that in the chat, there's probably at least a couple purchased while you were presenting. So R&L stock is probably a little bit less than it was when you started.
Well, the one problem people have been having is that if you buy them from China, it takes you a while to get them. If you get them and something's wrong with them, how are you going to get them fixed in any reasonable time frame? At least with R&L, they'll back it up, and you get a lot better service from what I've seen so far. And they've got a good reputation online with regard to reviews and things like that. So with this device.
I do have a question and a comment as well. I got mine from an R&L.
Yeah.
And I made sure I got the type N connectors because SMA connectors.
Yeah.
And it's definitely much more durable. And this goes up to 3 gigahertz as well. This is the SAA2N. It's the H4, but it's it's still the 4-inch screen. But actually, tonight was the first time I was playing with it.
Yeah.
I got it for my birthday back in November, and I just haven't really messed with it.
Yeah.
But I definitely wanted the type N's on there.
Yeah.
Just
Yeah.
a little more durable. But
Well,
when you work,
yeah.
go ahead.
Sorry.
Well, I was going to change subject. Go ahead. What you were going
That's
to
all right.
comment.
No, I was going to say, I found the SMA connectors okay. I've just been, kind of careful with them. And the one thing I have done on mine is I've put those extenders to save.
Connector savers.
Yeah, exactly. Because I didn't want to wear the gold out. There's
Right.
not that much gold in there.
No. That's a good point. That's another thing to consider as well.
Yeah.
What
Yeah.
part, when you were in Raleigh, where did you work?
I work for ITT. in Raleigh.
Oh, Matt, I
was
I
there for
moved up
20
there.
years.
I moved up there in '89.
Okay.
Richardson was the guy's last name. He was a ham radio operator, and I can't think of his first name. But I worked at Teletech,
Okay.
and between '89 and '91 until they went kind of belly up.
Was
But
it Chuck Richardson?
no,
Okay.
but he worked at ITT Mackey.
Yeah, in actual fact, the Mackey Marine receiver was what I used on the 0464 machine.
Oh, okay.
They had an engineering demo line run of about 10 units, and I got about 4 of them that
Nice.
they were going to throw away, and that was the 04 machine receiver for probably 15 years.
I'll be darned.
Hey, Kevin,
Richardson,
where did you get your Nano VNA that had the end connectors?
From R&L.
Okay.
And I paid, I think it was about $69.95.
Yeah.
Did
Yeah.
you say yours was the 3 gig version?
Yeah, mine's a 3 gig version.
Yeah, I don't think that's the huge version. I think that's the version 2 spur. So the firmware might be a little bit different. I don't know for
the
sure.
screenshots were the same as, as far as the menus and everything. They were
Yeah.
the same screenshots that you were showing just
Okay.
then.
All right. No, it
So-
should look a lot like. I don't think the units are very much different. You're right.
No. I just wanted the type N connectors, because I used to work for Spinner as well. And we made connector savers and stuff, and I've dealt with that. People
Yeah.
wearing out even type N connectors, but SMAs, especially when they over torque them. Not that I do that. I'm real careful with them, but it's just one of those things. I figured it's a more durable connector. I might as well. It was like
Well-
$5 more or something. So I said, okay.
Well, if you look at this device right here, there's the adapter from the VNA to the UHF.
Yep.
Now you talk about torque. You can put a lot of torque on that soldered SMA with this on there. So you're right. I haven't broken it yet,
No.
but I just use a small cable on the end of it to take the torque off of it.
Yeah, I just was concerned. I didn't know how the quality of these were mechanically, how strong they were. I just wanted to make sure.
Yeah.
So that's cool. But yeah,
You'll enjoy the device.
Yep. So that was North Boulevard back then. Then they changed to the Capitol Boulevard.
Oh,
So
okay.
that's where you ended up working there. Huh?
Yeah, I was
Very
there for
cool.
I was there for 20 years, and the telecom industry went through deregulation.
Yep.
So all of a sudden, we had a 95% layoff of 1,200 people.
Yeah, I remember all that stuff.
Yeah.
So
All right, Dallas, do you have a method for our door prizes tonight, which I think are HRO gift certificates again?
Yes, let me pick some random numbers. Number 69, number 8. Let's see who those come out to be.
Hey, John, may I interrupt?
Sure.
We never did announce the workshop.
I'm sorry. Yeah, go ahead if you'd like to announce the workshop before we get to wrapping up.
Normally I'd ask Dallas if he wants to do this, but he's already busy with the door prizes, so I'll go ahead provide this. Our January workshop, which is next Tuesday, the 19th at 7 p.m. on Zoom, is going to be Brian Herron. He's going to be talking about the Georgia Amateur Radio Situation Awareness Map. And definitely recommend to be there, especially if you're like Aries centristic. So anyway, so that's it for January. And we have speakers lined up through March. So we're doing pretty well on the workshops. And that's it for me.
Okay.
Add to that. The workshop in February, Lee will be right back here, but this time we'll actually do hands-on on testing things like maybe a bandpass filter, or take a piece of cable and look for a short on it. Maybe see the transition between 50 to 75 ohm cable. See what that would look like if you were to use this thing as a time domain reflectometer. More hands-on type stuff. Unfortunately, we don't get to do the hands. Lee gets to do that for us.
Sounds like a good one. Okay. What are the gift certificates? Do we know the value on those? Who's got that?
That's typically Norm, and Norm has been saying those were $25 gift certificates.
Norm, I saw Norm in there earlier. Do we have that? I forgot to ask before we got started. Norm may have dropped off. I'm not sure if I see him anymore in there.
We should just make it so. When we do in-person meetings, they are $25 gift certificates.
Okay, let's count on that being two $25 gift certificates. So Dallas, Mr. Random Number.
All right, so the first random number is Bob, Kilo 4, Charlie, Quebec, Oscar. And the second one is Stephen Dearman. Y'all still on the net here?
Yeah, I'm here.
I see both of them.
All right, there they are.
So Bob, our Garzette editor, K4CQO, and then Steve Dearman. I see him in there. And Steve, I forgot what your call is. You're muted right now. If you want to unmute, tell us your call. I want to say it's IXR, but I can't remember everything on it. Let me see if I can help you unmute. I'm trying to find you on the list here. You're unmuted. Go ahead. What's your call?
Steve?
Yeah, it looks like you're unmuted. Go ahead.
This is Steve Dearman, KI4IXR. I couldn't hear you, so I wasn't sure if you're referring to me.
Yes, sir. You're the winner of a $25 HRO gift certificate, which we will get to you.
Okay, sounds great. Appreciate it.
So, hey, that's you can buy some things to go along with your Nano VNA.
Absolutely.
I don't know whether HRO sells those or not, but at least RNL does.
Yeah, I need some accessories with it. I bought one from a ham earlier in the year for Christmas, and having a good time with it.
Good deal. Lee, thank you again for an excellent presentation. You've generated a lot of interest, I know, me included. And then if we're going to have you in the workshop here in February, that'd be great.
Okay, look forward to it.